wait until the match starts. It's going to go and move me. I'm going to respawn somewhere. Hopefully it's in a good section. Okay, here we go. Move along here, someplace that's a little bit more interesting. Okay, so let's see. All right. There we go. So this is like sort of normally rendered. This is with multi-res set to conservative, is what we call it. And this is multi-res set to aggressive. Now what you're seeing here is the inside of the 3x3 matrix is being rendered at like normal resolution. Everything along the periphery is being pulled out. So I'm going to go and toggle this. And so what you see here is that this is actually what I'm rendering, and then I'm stretching it. So this sections along the edge and along the top are being stretched to that. So you don't see any black part here because we're rendering it to the full screen image, but you get the idea. Let me move along here. Okay, let me toggle between these here. Here's another way of visualizing it. And if you're fill limited, you're going to be able to realize, all of that savings immediately. All right. There we go. Now we're looking at this in a desktop mode, so obviously it's going to be much more readily available because we're seeing everything at a 1-to-1 pixel ratio. We're not going through a lens warp. But it's pretty amazing, even in the cases of here, you can see some degradation along the edge as you move between the multi-res modes. Here, I'll see if I can show you on the monitor. So if you see, I'm toggling between the modes now. Okay, let me turn on the grid for you again. So you can see along like the left edge, for instance. So that's nothing on, that's like native resolution. That's what I would say is conservative, and then that's aggressive. But it looks pretty darn good. And in fact, we're exploring use cases of using this for desktop gaming, where we could, if you had a game, for instance, it was a first-person shooter or a third-person shooter, and the focus of the game is primarily in the center of the screen, you could probably use this to good effect because that's where people's attention is going to be most of the time, not on the periphery. And as long as the degradation was not too bad along the periphery, it would be a win. Another opportunity is to use, and we're experimenting with this, is eye trackers. So we're using desktop eye trackers, and then we're using multi-res, and we're moving that along. And even with a 60 hertz eye tracker, which is not that good, honestly, it's pretty amazing how well it works because multi-res kind of gives you what we would call a guard band, means like a safety border. So as your retina is moving along the display, that inset, which is at full resolution, is slightly larger than your eye is going to go on a per frame basis. So if you're watching somebody else doing this with an eye tracker, you're like looking along the edge and says, oh, that looks terrible. But the person who's doing it looks wonderful because everything is essentially being rendered at full resolution all the time because that's where their fovea is. That's where the primary resolution of rods and cones in their eyes are focused. Okay, so that's it.